In the vast three-dimensional world we live in, we are able to see, touch, and interact with everything around us, believing that this is the only existing reality in the universe. All objects have height, width, and length, and with these three axes we can perceive the world in a complete and tangible way. But what if there were more than that? For mathematicians and physicists, living in only 3 dimensions can be monotonous. That is why they venture into theories that explore extra dimensions, imagining realities beyond our perception. A fascinating example is bosonic string theory, which proposes a universe with 26 spatial dimensions. Welcome to Quantum Horizons. In today's video, we will explore the concept of extra dimensions, without diving too deeply into mathematical complexities. We'll focus on 5 dimensions, a number that already completely challenges our intuition. Before reaching that point, let's start from the beginning, a world without dimensions. Imagine a universe where nothing extends in any direction. This world would be reduced to a single point, a space without height, width, or depth. Its description can be summed up in one sentence: it is a point, and nothing more. Now let's move on to the first dimension. In the one-dimensional universe, everything can be represented by a single parameter. This may sound abstract, but there are examples in our world that fit this concept. Think of a train journey between 2 cities. The displacement can be described solely by the distance between departure and destination, with no need for other coordinates. In this world, objects can only move forward or backward without overtaking each other, unless, somehow, 2 mischievous cats decide to defy the laws of physics. The first dimension may also not be related to space, but to other concepts. A practical example is a thermometer. When we check the temperature, the reading boils down to a single numerical value indicating whether we should leave home wearing a coat or shorts. This example has a peculiarity: temperature has a lower limit, the so-called absolute zero, minus 273.15 degrees Celsius. However, it has no upper limit, temperature can increase indefinitely. Now let's think of another application of the first dimension: time. When we count years from a specific point on the timeline, we can move both forward and backward, reaching infinite values. Here arises a great question: what existed before the Big Bang? Did time have a beginning, or was there something before the birth of the universe as we know it? If this mystery is already intriguing, imagine what awaits us when exploring higher dimensions. Have you ever wondered if time has a limit? Imagine a 2-dimensional world where everything is represented in just 2 dimensions. The inhabitants of this world would be figures such as squares and circles, and their reality would seem like a flat surface with no depth. But is it really that simple? Let's take Earth as an example. With only 2 parameters, latitude and longitude, we can identify any point on the globe. This means that even 3-dimensional systems like Earth, Mars, and the Sun can be represented in a 2-dimensional system. Now let's return to our world, which we believe to be 3-dimensional. Our perception of reality is based on shapes like cubes, spheres, and cylinders. This 3-dimensionality is the foundation of all modern physics, or almost all, because in fact there are things physics still cannot explain. For example, scientists have not yet been able to create a theory that unifies quantum mechanics and general relativity, the so-called theory of everything. To solve this enigma, some believe we need to consider extra dimensions, such as a 4th or even a 5th dimension. But how can we imagine the 4th dimension? The simplest way is to add a new element to our analysis: time. Suppose we are observing a rocket standing still at a point in space. If we look at the same point 1 second later, the rocket will no longer be there. This shows that, to represent the functioning of the world, time is essential. However, time seems to follow only one direction, always forward. Even if we wanted to go back to the past, we have no control over it. Yet this feature has its advantages. After all, we have always accepted that time flows in only one direction. Until scientists discovered something surprising, they realized that, when observing the light of stars located millions or even billions of light-years away, we are in fact looking at the past. The Sun, for example, does not appear to us as it is right now, but as it was about 8 minutes and 20 seconds ago, the time it takes for its light to reach Earth. Thanks to this effect, astronomers can observe events from long ago, such as supernova explosions, and even trace back to the early universe through cosmic background radiation. This leads to a big question: Does time really have a limit, or is it just another dimension waiting to be understood? From the very beginning, the study of time has been one of the most intriguing subjects for physicists. It brought with it countless mysteries and challenges. To illustrate, in 1964, the American astrophysicist Erwin Shapiro suggested that the sun's gravity could affect the transmission time of signals between two celestial bodies. This phenomenon became known as the Shapiro time delay effect, and was later confirmed between 1976 and 1977. In this fascinating experiment, radio signals were sent from Earth to the Viking 1 and Viking 2 probes, which then amplified and retransmitted them back. Scientists observed variations in response time as the probes moved closer to or farther from the Sun. The results were astonishing. When the probes were near the Sun, signals from Earth suffered a predictable delay. Researchers concluded that this anomaly was caused by the curvature of space generated by the Sun's gravity. The closer a signal passed to the Sun, the longer it took to arrive at its destination, as the surrounding space was distorted by the star's immense gravitational force. This situation can be compared to a journey where the traveler suddenly finds himself before a deep abyss. The greater the mass of a celestial body, the more intense this deformation becomes, creating an even deeper gravitational well. According to some theories, this distortion of spacetime could form a structure called multidimensional hyperspace, going beyond our usual perception of 4 or 5 dimensions. In fact, this suggests that our universe may contain additional dimensions we cannot see. Although this idea seems to contradict our intuition, it has been explored for centuries. In 1884, the British writer Edwin Abbott introduced this notion in his book Flatland. In the story, the protagonist is a square who lives in a two-dimensional world. Every 1,000 years, a three-dimensional sphere appears in his universe. However, the inhabitants of that world cannot recognize it as a sphere. All they see is a blue that, when touching their plane, begins to expand into the shape of a circle. This circle grows until it reaches its maximum diameter, when the sphere's equator crosses the plane, and then gradually shrinks until it disappears. This fascinating concept leads us to wonder, could we also detect evidence of the existence of higher dimensions? Although we cannot see them directly, perhaps we can perceive their effects and even predict their structure. That is why scientists have long explored this idea. For example, in a four-dimensional space, a cube would be represented by a structure called a hypercube or tesseract. If you are a fan of the Marvel Universe, you have probably heard of a certain mystical artifact that contains the power of space. In a universe where science and imagination intertwine, the mysterious cosmic cube played a crucial role. Loki, with his cunning gaze, used this artifact to open an interdimensional portal. In an instant, Grand New York became a scene of destruction and chaos. But what if we told you that in the mathematical world, this object is not seen as a weapon of immense power, but rather as a fascinating geometric structure? We are talking about a fourth-dimensional hypercube, a shape that challenges our perception of reality. This enigmatic object has 16 vertices and 32 edges, making it something completely out of the ordinary. And when it begins to rotate, everything becomes even stranger. Just as a cube can be unfolded into 2 dimensions, the hypercube can be unfolded into 3 dimensions, and there are no fewer than 200 ways to do this. Among these possibilities, one stands out: the intriguing Dalí cross, named after the famous Spanish painter Salvador Dalí. Inspired by the ideas of a fourth dimension, Dalí created the work Crucifixion, Corpus Hypercubus, where he brilliantly blended art and mathematics. But think about it, don't many of this Catalan genius's paintings suggest different dimensional perspectives? Now, if the fourth dimension already defies our imagination, what can we say about the fifth? In this even more complex domain, a hypercube becomes an entity even harder to conceive. It has 32 vertices, 80 edges, and 80 faces. And if we observed the rotation of such a structure, what would we see? Something our minds, so accustomed to three-dimensionality, can barely grasp. But don't think that scientists create these models out of pure curiosity. On the contrary, they study these geometries because they believe they may help us better understand the physical phenomena of our universe. And with the relentless effort of physicists and astronomers, perhaps one day we will be able to unravel all the mysteries of the cosmos. However, there is one challenge: the human perception, naturally limited to the third dimension, may never allow us to see everything clearly. But that is precisely why this channel exists. We are here to fill this gap and bring you the most incredible discoveries about the universe. So don't forget to subscribe so you won't miss any new videos. For now, it's time to say goodbye. If you enjoyed our content, leave your like and share this video with your friends and family on social media. And if you're still not satisfied, don't worry. We will keep challenging ourselves and bringing even more interesting videos. Stay tuned for our next topic. See you soon.